Unit accelerated class, so I know you guys are a little excited. You guys just wrapped up your unit exam on proportions, ratios, unit rate, and of course markup, discount, and percentages. We're going to go ahead and definitely keep on working on solving multi-step equations and isolating a variable, but we're also going to start working on graphing inequalities with one variable. This is an inequality with one variable, and that variable is m. It kind of looks like solving an equation when we isolated this variable m. See, here's what this equation is now changed into. The inequality that says 4 times m plus 2 is greater than or equal to 6. So there's a number that if I multiply it by 4 and then I add 2, I should always be equal to 6 or greater than 6. Well, a lot of you guys can probably do this in your head and say, well, let's see. Isn't 4 times 1 equal to 4 and 4 plus 2 equal to 6? So I think m has to always at least be equal to 1. But let's see how we would have isolated this. We're going to take away 2, and we're going to go ahead and balance this by taking away 2 from the 6. This is going to go ahead and give you 0, because 2 take away 2 is 0. 4 times m now has to be greater than or equal to another number, 4. Well, now we know 4 times 1 has to be at least equal to 1 if we multiply it. So 4 times 1 has to be greater than or equal to 4. So if I divide by 4 and balance this, I'm going to go ahead and get m has to be greater than or equal to 1. See, if you take any number and you use it that it's greater than 1 or bigger than 1, let's use an example here. Let's say that m is equal to 3. If you use m is equal to 3 in our inequality here, 4, we're going to multiply this 4 times 3. And then we're going to go ahead and add 2. If this isn't greater than 6, there's a problem. Well, let's see, 4 times 3 is 12, and 12 plus 2 is equal to 14. Well, 14 is greater than 6, so that's fine. Well, what happens if I go ahead and make this m equal to 2? Will it still be okay? Well, according to our inequality, as long as the variable is greater than or equal to 1, everything should be fine. So what we'll do is we'll replace this with the number 2 right here. And then we're going to go ahead and see if we still get something greater than the number 6. 4 times 2 is equal to 8, and 8 plus 2 is equal to 10. So as long as the variable is greater than or equal to 1, this inequality is true. But how do we graph that? Well, I definitely want to show that m has to be equal to 1 at least. Because 4 times 1, if I choose 1 here, I'm going to get this instead. And this is equal to 6. Because 4 times 1 equals 4, and 4 plus 2 equals 6. So I need to show everyone, hey, m has to be equal to 1. So what you do is you put a solid colored in dot, a circle, on top of the number 1. Well, how do I show everyone that it has to be greater than 1? So I want everyone to understand, this is the side, the right side of 1, where it has to be greater than. Well, this is where a lot of graphs will go ahead and color in everything all the way up to the arrow tip. When you color this in all the way up to the arrow tip, this is going to go ahead and say, as long as m is equal to 1 or greater than 1, it's fine. This is our introduction right here. But I want to show you guys something pretty interesting. What happens if I have a really simple inequality? What happens if I just have 4m has to be greater than 8? You're probably thinking, well, this is easy, right? But what happens if I make it a negative 4 instead? Now you're probably thinking, wait a minute. The only way that this is going to be greater than or equal to 8, because if I have a positive number, let's see what happens. If m is equal to 1, what's negative 4 times 1? That's going to be negative 4. Is negative 4 greater than or equal to 8? No. So what's the only way that we could be greater than a positive 8? This variable must be negative. So what we're going to do is we're going to go ahead and take this inequality and we're going to divide it by negative 4. Here's a very special rule that you have to remember. When you balance your inequality, this m is going to go ahead and have a very special rule. This inequality is going to go ahead and turn the opposite direction. Now you're probably wondering, wait a minute, why is it going to turn the opposite direction? I'm not understanding that. Well, I need you guys to understand, in order for this inequality to make this true, see, -4 times a number had to be greater than or equal to +8. Give me some numbers that are less than -2 on the number line. Well, let's see what's numbers less than -2. -3 is less, and any number on the left of it is less. So let me choose m is equal to -3. What happens when you substitute it in? Let me put in -3 times -4. What's a negative times a negative? It's a positive. And isn't 12 going to be greater than or equal to 8? And that's how you check it. That's how you know that switching this inequality the opposite direction will make it true. So I put my colored in circle right here on top of the number -2, and now I need to color everything on the opposite direction. This is a very special rule, and we're going to be talking about that more as we get into this topic. Catch you guys next time.